This is the video for section 8.1 notes, slides 2 through 4. All right, so for Unit 8, we are talking about area in section 8.1, and then in 8.2, we'll be talking about volume, and in 8.3, we'll be talking about volume, and then in 8.4, we'll be talking about something called work. All right, but for section 8.1, area between two curves. All right, so it says if f and g are continuous functions with f of x greater than or equal to g of x throughout a to b, then the area between the curves y equals f of x and y equals g of x from a to b is found by the definite integral from a to b of f of x minus g of x. All right, so this is actually a fairly simple concept here. All right, so let's say that I have two functions. All right, so I'll say f is this graph here. So let's say f of x, and let's say g is this graph here. Let's say, all right, here's g of x. All right, and so now, okay, if we think about this integral, all right, we can realize that really you could say, well, this is just the integral from a to b of f of x dx minus the integral from a to b of g of x dx, right? So really it's just, okay, well, what's the area underneath f from a to b? All right, so let's say here's a and here's b. All right, now we were told that f of x is greater than or equal to g of x the whole time. So f of x has to be either above or equal to g of x every time. So I just made it above. All right, so what does the first integral represent? The area underneath f from a to b. All right, so that would mean that I'm looking at this area, right? So I'm going to draw it like this, all right? All right, so that's what that integral represents. All right, now, what about the integral from a to b of g of x? Well, the integral from a to b of g of x, that would just represent this area. And so, what are we trying to do? Well, we're trying to find the area between the curves from a to b. And so that means I am interested in this area. Now, if we took the bigger area and we subtracted this smaller area down here, then don't we have this area in between, right? And so that's all we're really doing, all right? Now, the key here is that making sure we actually know what the graph of each item looks like. And we're also going to have to use our calculator some, because some of them we are not able to get the graph without our calculator, or we're not able to find out where A and B are. So we've got a couple examples here. So let's go on to slide number 3. All right, so slide 3. It says find the area of the region bounded by y equals x to the fourth and y equals 2x minus x squared. All right, so this is the graph. All right, now you should be able to get these graphs without a calculator. All right, so obviously x to the fourth, you know it should look like an x squared graph, right? It's a little flatter here and it grows a little quicker outside of 1 and -1. All right, but you should be able to draw that. All right, now the next thing, all right, y equals 2x minus x squared. How would you know that it is this graph? All right, well, for one, it's quadratic, right? And its leading coefficient is negative, so it has to be facing downwards. All right, but now, how would you know otherwise? Well, I would say, okay, well, I want to find the zeros, right? So I would set it equal to 0. So if I do that, I could factor out x, and I could get 2 minus x, which means that x equals 0 and x equals 2, right? So that means a parabola facing downward has zeros at 0 and 2, so it would have to resemble something like that, right? All right. Then, all right, you'd have to know where the two curves intersect each other, right? So you'd have to set x to the fourth equal to 2x minus x squared, right? Well, now that's a little bit more challenging, right? Because I have x to the fourth, let's see, plus x squared minus 2x equals 0, right? And, well, this is okay because you could factor out an x, right? And then you'd have x cubed plus x minus 2 equals 0, right? But then you'd have to use like a plus or minus p over q situation to figure out the zeros of that other part and to get that 1 is the other intersection point. So obviously a little bit more challenging. But if I give you the picture, really this is no big deal, right? All right, so how would we find the area bound between them? All right, so remember, the area bound between them is this area. So the first thing that you have to ask yourself is what function is greater than the other function at this point? All right. So the upper function here is the 2x minus x squared, and the lower function here is the x to the fourth. So I would be integrating the upper function minus the lower function. All right, so what is the upper function? 2x minus x squared minus the lower function, which is x to the fourth. Right? I'm going to integrate that with respect to x. Now, I'm integrating from a to b. So from left to right, that would be from 0 to 1. So that's it. Okay, that's the integral. So now it says find the area. So how do I find the area? Well, I actually have to carry out the integral. All right, so integral of 2x is 2x squared over 2 minus integral of x squared is x cubed over 3 minus the integral of x to the fourth, which is x to the fifth over 5. Okay, now this is a great example. Yes, I have x squared, x cubed, x to the fifth, but remember, I'm only plugging in 0 and 1, right? So this is really no big deal. All right, so I get, well, the 2's reduced, so I get 1 squared minus 1 cubed over 3 minus 1 to the fifth over 5, right? So that's the first part. Then I have minus 0 squared minus 0 cubed over 3 minus 0 to the fifth over 5. Okay, so obviously that all is 0. So I have 1 minus 1/3 minus 1/5. Okay, so really not bad at all. So this is 15 fifteenths minus 5 fifteenths, and then minus 3 fifteenths, right? So 15 minus 5 minus 3 is 7 fifteenths, right? So this would be a great example of a problem that AP would make the numbers very easy. This is very much a non-calculator question, right? Assuming that they give you the graph, of course. But if they don't give you the graph, it still could be done, but it's probably more than they want you to do in terms of like having to use like plus or minus p over q to solve that equation. So definitely a non-calculator question, and they would make it pretty reasonable. All right. So now, example number 4. All right. So now it says find the area of the region bounded by y equals 2 cosine x and y equals x squared minus 1. All right. So you know what both of these graphs are, right? You know that 2 cosine, right, of course, is a cosine function, right, with an amplitude of 2. So, you know, it goes up to 2, down to negative 2, right? And it has a period of 2 pi, right? So here's a graph from negative 2 pi to positive 2 pi of the cosine function, right, of 2 cosine x. All right, now, y equals x squared minus 1, you know that, right? Just a parabola shifted down 1, right, like that. So now, I guess you'd have to say, okay, well, I know that these two would meet somewhere here and here, right? But not exactly, right? But you could still determine that cosine would be above this one for wherever they are, right? Okay, so now you could do that, but the problem is now that, well, you don't really know these points of intersection, because if I think, okay, well, when do 2 cosine x equal x squared minus 1, well, that's a problem, right? Because I can't solve that, right? I would have to use a calculator to do that. And so that's actually what we want to do. We want to use a calculator, right? All right, so let's pull up our calculator. All right, and so now what you want to do is you are going to graph the two equations. So I'm going to graph 2 cosine x. All right, and then I'm going to graph x squared minus 1. All right, so I do that. All right, now, if I do this, I get that, well, okay, you can see it, but you probably want to adjust your window, okay? So, I don't know, maybe like negative pi to positive pi, all right, and then scale, like, how about negative 3, all right, y min to positive 3, right? Okay, so now I hit graph. Now, okay, I get, like, the picture that I would have expected. Okay, now I still need to know when those two things meet. So how do I do that? I do second trace intersect, right? Number 5. All right, now first curve, is that the cosine? Yes, so I hit enter. Second curve, is that the cosine? Yes, so I hit enter. All right, now it says guess. All right, well, I know this one's going to be here around positive 1, so I'm going to hit 1. All right, so now I'm going to get that intersection on the right. So I get that x is equal to 2.65 1.2654, right? So I'm going to round to 3 decimal places, 1.265. All right, so this is 1.265, comma, and I'll write down the y value as well, 0.601, right? So 0.601. Now, you could get the other side, but by guessing like negative 1, but you should know that this thing is